today we'll do another video, and today we'll continue on what's called digital logic. Digital. Well, if I got a marker that works. Digital logic. Okay, so it's going to be a video. It's going to be a kind of tedious. It's going to be, I cannot promise, but it's going to be a short video. But it's going to be kind of one of those. So based on this topic, we will do what is called SR flip-flop. So to do that, we will start by creating some tables. And we'll start by creating some table that allows us to see, the logic, right? Because it's going to be digital logic, right? Zeros and ones. However, we need to understand the tables, what each table does, right? Based on each gate, right? So we have, and these markers are not working. Is it this one? This is not working either. Interesting. Okay, I guess I will try to use this one. So we have N, right? N gate, and we have what is called A, V as an input, right? And as an output for the N gate, we have 0, 0 is 0, 0, 1 is 0, right? 1, 0 is 0, 1, 1 is 1. That's the N gate. Okay, so now, based on that, let's do what is called a NOR gate, right? NOR, which means not or, right? Not or. That's what I'm saying. If I am saying not A or B, is not or, right? Not an OR gate, right? So in this case, we have A, V, right? And we have output, right? Output. So if we have an output, right, and we have A, V, 0, 0, right? This is the tricky part, that because I'm saying not or, which means that the regular or, A, if A is in a regular or, right? If I have a gate like this, right? A, V, if I say this or, right? The output, if this is 1, this is 0, this is going to be 1. That is an or, right? If I switch this, the same thing. It's going to be either A or B is equal to, have to be equal to 1 in order for our OR is equal to 1, the output of the OR, right? Well, in the NOR gate, it's the opposite. So I'm saying not OR, right? So the logic saying that I need to negate that. Not OR means that the only case where this is going to be true is when both are definitely 0, and then I got a 0, I got 0, 1, 1, 0, 1, 1, and the rest of this stuff is 0. Okay. There is another one that's called exclusive OR. We're not gonna use this one in this one because it's not really necessary, right? But exclusive OR means that it's exclusive OR, which means that these two guys are zeros and these two guys are always one. That's called exclusive. If I am, I'm saying exclusively OR, right? But in this case, we're not going to use that. So we're not gonna use that. Okay, so now we have the two gates, right? And NOR. Now we need to do a table for the SR Latch, which is going to be technically the SR Latch, right? So it's going to be a little table like this too. SR Latch, right? If you didn't watch the last video, I will suggest to watch the last video in order for you to understand this better, right? Because I explained about the SR Latch last time. So, okay, so in the SR Latch we have SR, right? For the SR, right, it's based, the SR Latch was based on this guy, based on the NOR, right? So, in order for the SR Latch to be true, the only way that this makes sense is going to be this guy is going to be equal to 1. However, because the SR Latch is it depends on the previous of the inputs, right? So it's like, you remember, it's like the memory of the chip, right? A chip of a microcontroller, or a computer. A memory of the computer is remembering that you did something in the past. Even though the computer is off, you turn it off. But if you go back and check, the computer will say, well, you did this, right? It will keep that in memory. Same thing, the same idea. So the SR Latch pretty much does the same thing. And that's why we make the table, when we make the table for SR Latch, we make it in the form of I don't know if I want to do that over there. Might do it over here, I think, because I need a little more room for it. This is not, yeah. I need to do it over here because I need to write some description. So, okay, so let me do it over here. So SR Latch. Right. So right here, do AB and output. Now, so it is similar to the NOR, but it takes a little more thought about it. Well, it's basically from the NOR gate, right? It's basically from the NOR gate. But like I said, so 0, 0, the only one is the only one is going to be when the NOR gate, right? Let's say, for example, both the input and the output is equal to 0. Okay? That might be true. But the bottom line is that what if the the previous state was 1 and that 1 is saved in memory, right? So so um so what we say in this is like if 0 is 0, we say there is no change, right? If 0 and 0, there is no change. There is no change in the previous state, whatever that state was. That's what we mean by that. No change. If the previous state was 1, of course, it's going to be 1 even though there is no input. A and B is equal to 0. Now, if we set, if we set, actually this is SNR. SR, right? If we set to 0, and we change R to 1, that means that we set Q, matter of fact, Q, we set Q to 1, right? And matter of fact, because there are different ways to do this, different way. When you understand that what you do, you can put an output. You know it's going to be an output of two different it's going to be two different events that will happen, right? But it can only happen one at a time. That's what I'm saying. So it's going to be Q and Q not. Okay, I guess that would make better sense. But anyway, so I understand the output, but I guess if you understand this better, you do it that way. So now what we're doing right here is the following. So we set Q is equal to 1 if we set up S is equal to 0 and R is equal to 1, we set Q equal to 1. Now, next, we do 1, 0, right? See, it looks similar to this one, right? In this case, we reset Q equal to 0, right? Reset Q equal to 0, right? When we reset Q equal to 0, Q naught is going to be equal to 1, right? Reset Q equal to 0 and Q naught is equal to 1. So, right, reset Q to 0, right? And Q naught at this point, when we reset Q is equal to 0, Q naught should be equal 1. Okay, now, we have a last one. When we set up both at the same time like this is not valid. When you set up S and R to 1, this is not valid. And the reason why is because you press 2 at the same time, and it would make both zeros. And you cannot have one. You cannot have those, right? At the same time. You got to have either Q or Q naught is equal to 1. But anyway, so let's do that. Let's do the, you will have a better understanding when we do the drawing here. So, okay, so we start by S, right? We start with AND gate. We start with an AND gate, and then we start with something like this, right? And with that, we start another AND gate, another AND gate, right? So now we have something like this, right? Now, here we have what's called CLK, which means clock. This is a clock, right? So you're pushing, right? You're pushing this. This is a clock, right? You push this, you send a signal either here or here at the same time. I hope that makes sense. Now, you press the button, whatever, you press the button. When you press this button, it will send a signal to both AND gate at the same time. So this is R. Actually, the reverse. This is S. This is R. This is S. Okay. So now from there, we have two AND gates, right? So now we have. Notice that we have, remember in the SR Latch, we only have two NOR gates, right? We're dependent on R and S. In this case, we will have R, but it's going to be it's going to be a combination where you have an AND gate before that. It's going to be R prime. We call this R prime. We need to call it something now. We need to differentiate, right? R prime and S prime. Why? Because now we have this R is going to go through. It's going to go through this R, R prime and S prime. They are the same values coming in. I mean, it's of course it's going to change now because you have an AND gate. But whatever is coming in over here is going to be the value for this, right? Do not confuse. This does not mean. This does not mean R not or S not. It doesn't mean that. It just means that we have an input. We cannot call them the same thing, right? We need to differentiate them. Okay, so let's do this. So now we have an OR, right? I hope you remember that from last video that we had an OR gate coming in like this. So it's an OR. This is kind of even worse. Because this is not cooperating. So, all right, so we have this is the first OR gate. All right, so that's the first OR gate. That's the second OR gate. Now right here, I got something like this. Right? Then I have something like this. Now you press part of this. All right. So right. So we have right. So we have this, right? And right here, because it's an OR, we add little bubbles. I am saying not OR, right? So in this case, I have the following. So I have Q and I have Q bar, Q naught, right? Okay, so what does this mean, right? Now, this is N, and I don't know if we'll be able to see, but this is N, and these are NORs. Not ORs, right? Okay. Based on this, we have to create another truth table. So, in this truth table, so I will just do little by little because I want you to understand this. I mean, these are kind of tedious. I will say this is a tedious work. That's what it is because it's not a lot of math. It's just analytical stuff. It's not a lot of math. Okay, so but unfortunately, we're taking electrical engineering. Sorry, but you got to go through this. Unless you're taking some type of technical degree that doesn't require this. But if you're regular electrical engineering, most of the time you got to do this. Okay, so let's do this. So let's do CLK. Let's do SR. So do SR. Okay. SR, right? Well, what is coming after SR? So we have S prime R prime, right? And what comes as after R prime and S prime? We have Q and we have Q naught, right? So now, and what do we have after Q naught, right? Well, this is the output. So right? Okay. So technically the Q naught is output, but we need to kind of be specific what we're doing here. So okay, so we said output. Okay, this is when the fun starts. Let's say now everything is zero, right? This is 0, this is 0. And we said that there's no change. That was before the Obama era, right? Obama said there's going to be some change. He didn't specify what change it was, but no change, right? Before the Obama era. Okay, so now this is 0, and of course this is 0. We can, this is 0, right? No change, so we can put X aside, no problem. No change in this, remain in 0, right? So no change, because why? Okay, think about it. Okay, think about it. Let's think about it. This is about thinking a little bit analytically. The clock has an input on both AND gates, right? It does not matter what the value of R and S is. Again, it does not matter what the value of S and R is. Why? Because the AND gate, if one of the input is 0, the rest is 0. See? It doesn't matter. Okay. But it's going to change eventually. So, so let's see. So now, right here, this guy is 0, this guy is 0. And of course, 0, 0, no change. Next, we set the clock equal to 1. Clock equal to 1. Now we say that S and R are zeros. Well, think about it. Clock is equal to 1, right? Okay, in this case was 0, right? No change. We got that. Okay. Now let's change the clock to 1. Clock is equal to 1, and then guess what? Is anything changing? No, it doesn't change anything. Because technically clock is equal to 1. Clock is equal to 1, but then this is still 0, right? Because it's AND gate, right? So no. So this is actually, again, right? It's going to be 0, 0. Let me clarify that SR is equal, the SR values are equal to SR, S prime and R prime values. Okay, in other words, S is equal to S prime, R is equal to R prime. I don't want people to get confused, right? So whatever we put in over here, we need to put it over here, right? No problem. Now, let's think about this. Now, if this is 0, this is 0, well, and then let's work this out. Now, we actually, okay, so initially we start by doing this, that something like last video, that at that moment Q naught was 1. When nothing was, assuming that something was turned on, Q naught was 1, right? Next, we set up this, right? What's happened over here? We set up clock is equal to 1, but this is equal to 0. So this one, in this case, right? Clock is equal to 1. This is 0 and 0, right? Let's say, for example, 0 and 0, right? Again, the same thing. No change. Or in this case, you can say no change. No change. Or something was saved in memory. Or you can put memory. Next, Next, right? We set up this guy, so we keep the clock at 1, right? We set up S to 1. Okay? So we set up S to 1, right? Now, you gotta be careful with it because S equals 1 now. This one comes in. See? This one comes in, right? You got a 1 coming in for the clock. And 1 coming in over here. This one make a 1 over here, right? Make a 1. Now, this one coming in over here. This one coming in over here. So we have a 1 here, right? This one coming in, get to the SR Latch, and then 1, but technically, previously, we had a 0 here, right? There was a 0 coming in, right? It was a 0 coming in, so therefore, this is 0, right? So, we had a 0 coming in, right? And then we have a 1. Well, at this point, we have 0, we have a 0 and 1, or you can use this, right? So we had a 0 and S on R, but we had a 1, right? So they have in this situation, right? So in this case, we have a 1 on S, but we have R is equal to 0. So what's going to happen? Now, Q naught, in this case, Q is equal to 1. See? Yes. So Q is equal to 1. In this case, if we do that, it's going to be 0, right? 1, no, yeah, 1, 0. And over here, Q, okay, let's do this again. Okay, so we have a 1, right? This was 0 initially, coming in. We have a 1 over here, but then we have 1 over here. This one is coming over here, so we had Q was initially set up to 0, right? Q was initially to 0. We have a 1 and 1 coming in. That 1 and 1 coming in this becomes a 0. It's a good, and you know, we need to understand this, because now this comes to here, right? And then this goes up. Okay, so this goes up and feed this. This 0 comes over here and feed that. 0 and 0 is equal to 1. See? Now this guy right here, and I want you to kind of pay attention to this. When this 0 comes over here and fed this, which was 0 right there, this 0 and 0 make this statement true, right? Which is 1. So now Q is equal to 1. See that? It's very important to understand this, right? So now Q is equal to 1 and Q naught is 0, right? We just proved that. It's right there. Now we say set Q to 1. Next, we maintain, let me erase this because it's easy to get confused. We maintain the clock to 1. Clock still 1. We turn we set 0 for S, reset, right? We set 0 to S to 0, right? Or we can say reset, right? So we reset S to 0 because it was 1, now it's 0, and then we set Q to 1. Set reset, right? Now, what we're doing by setting this to 0, we're resetting Q to 1. That's what we do. Hopefully this makes sense. And this is the same, right? Over here. Coming through. Now, look at this. If we set S to 0, right? S to 0, right? So we had 1 previously coming in from this guy. We had a 1 previously coming in, right? We had a 1 previously, right? That was a 1 coming in. We set this guy to 0, right? When we set this guy to 0, this guy is going to be 0 right here because it's an AND gate, right? Got a 1 over there, but then we set this equal to 0. This is coming to 0. This 0 is coming in to this OR gate, making 0, right? Now, make it a 0, and then the NOR gate, right? So coming out 0, this 0 right here, as you know that this 0 coming in from here because it's a NOR gate, right? Because it's a NOR gate. So okay, so let's start this over. Okay. So initially S was 1, R was 0, right? And S not was 1, right? Because it was 1. And then R was 0, right? Was 0 coming out. That gave us we set up Q equal to 1 and Q naught was equal to 0. Okay, now we reset. We put S equals 0, R is equal to 1. S is equal to 0, and an AND gate is 0 coming out, right? Now, there was a Q coming in. The Q was equal to 1 coming into this gate, right? To this NOR gate. But then, that NOR gate is equal to 0 when that happened, right? So, the output of the NOR gate is equal to 0 when that happened. Right here, right? Because we're saying that we are in this state, right? We're setting A, we are here setting S to, we're setting S to 0. Yes, S to 0 and Q, but in this case, right? No, S to 0 and 1 at R, right? So we're saying that we have a 1 over here, right? Let's okay. So we have this 1 comes in, goes over here, right? Now this 1 comes in. This and this is 1. This and this is 1, right? We have a 1 coming in, but that one, right? That one gets inverted back to 0. Why? Because it's 1 not, not 1, another 1, it's 0 coming out of here, right? This is a 1 coming in, after being fed, right? Coming on. But this is an OR gate. When this is an OR gate, that means that I am doing the reverse of that, which is a 0 coming out, right? 0 is coming in, and then that changes that from being 1 to being 0 from the previous state. Now Q is equal to 0, right? Feeding this back signal to this, and we had a 0 coming in, so which mean that Q now is 0 and Q naught is equal to 1, right? We reset. Right? Reset Q naught to 0. Reset Q to 0, right? Reset Q to 0, which in this case Q naught is equal to 1. Reset Q to 0. But in this, what I'm saying is reset Q to 0, which that's what happened. Reset Q to 0, which the output of that, the result of that is we reset Q to 0 and set Q naught back to 1. Okay. One more last step. So we try, right? The combination, we try 0, 0, 0, 1, 0, 0, 1, 0, 0, 1. We try those. Now let's keep the clock at 1. Let's keep the clock at 1 and let's do 1, 1 for both. When we do 1 and 1, think about it. Let me just write this because it's easy to get confused. All right. Right, so you maintain the clock to 1. Now, we claim that we're setting this guy to 1 and this guy to 1, right? 1 and 1, in this case, is, right, is 1 coming in, out. And I got a 1 and 1, another 1 come out. Okay? Now, we had previously, we had a Q naught was 0, right? I know Q was 0 and Q naught was 1. Think about that. So I wrote this down just because I don't want it. I need those, but it's easy to kind of raise them up and then start with whatever you need because it's easy to get confused if you have a bunch of assigned values to S and R and S prime and R prime. Yeah. So now that we have this, that was the previous state. Now, if you think about it, I got 1 coming out, right? And I have a 0 out of this coming out. When I have 1, 1, right? I got a 1 coming out, a 0 coming out. When I have a 0 coming out right here, I have a 1 and 0, which that make that statement true. I have 0. Now, go back. So in this case, right, because we have 0 and we had a 0 coming in, right? But this is equal to 0, but this 0 coming in over here, the output of the 0, because this is technically a 0 coming in from the previous, right? That equals 0. which means that Q naught is 0. Okay? Go back over here. 1 and 1 is equal to 1. So we have a 1 coming in. That 1 gets fed into this, right? And then this get NOR with that, which is also is equal 0, right? Is equal 0. Remember that this was 0. This was the output of this was 0, but this 0 gets fed into this, right? But this coming in is 0, right? Back. So the output of this is also 0, which is invalid. So not allowed, right? You press 2 buttons at the same time, not allowed. You know, that's the reason that is the reason that it's called SR Latch or SR flip flop. You got a flip flop, okay? Like politicians that like to flip flops a lot. Okay, thank you for watching and have. I hope you enjoyed the video. If you enjoyed this video, please give me a like and have a good day. Thank you for watching.